Hello friends, welcome to Damu Education. If not yet subscribed, please subscribe and click the bell icon. So in this module, we are going to discuss our fifth question. ABD is a triangle at angle, right angle at A, and AC is perpendicular to BD. AC is perpendicular to BD. That is, if you take this triangle, right angle, and this is a hypotenuse for the BD, if you consider as a triangle, this is the height, altitude, you can take it. Show that AB square and equal to BCBD. So what are the given conditions? Let's write it first. Given that, so ABD, triangle ABD is right triangle, and angle A will be equal to 90 degrees. So angle A will be equal to 90 degrees, and here AC is perpendicular to BD. AC is perpendicular to BD. That means AC is making 90 degrees with the BD. So what is required to prove RTP? So required to prove, first one is AB square, this side square will be equal to BC into BD. So BC into BD. Second one, what is that? AC square will be equal to BC into DC or CD. Third one, what is that? AD square will be equal to BD into CD. So BD into CD. So these are the consider things. So proof first one. Let's consider, let triangle. So here AB and BC and BD. So we need to take this entire triangle and ABC triangle. So let's consider triangle BAC and triangle. So B, we are started at opposite to the height of the triangle. So BAC, right? You can take it as BDA. B as it is DA. So why? Because here angle at 90 and here A is a 90. B is a common, and A here in this triangle A is a 90 degrees and D is a side. So for this one you can take this one like this. So what is the things? So angle BCA in this triangle will be equal to angle BAD. Why? Because here it is 90 degrees. It is 90 degrees in both the triangles. This is 90 degrees. So right angle triangle. Next one, common angle. What is the common angle in both the triangles? So angle ABC, here this angle is a common in both the triangles. Angle ABC will be equal to angle DBA or ABD. You can take like that, ABD. So that is common angle. So what you can write here is by AA similarity criterion, what you can write here as by AA similarity criterion, triangle BAC is similar to triangle BDA. So these two triangles are similar to each other. Then what you can write here is corresponding sides of, so write the statement, corresponding sides of similar triangles are in same ratio. You can write like that, or you can write ratio of corresponding sides of similar triangle are equal. So let's consider here BA. Let's take it BA. So in this triangle BA, that is hypotenuse whole divided by BD. So hypotenuse in this triangle, this hypotenuse and this hypotenuse, and you can take it as BC is a base. BC is the base. For this BA is the base. BC by BA. So how I am taken here is, so in this triangle ABC triangle we are taken hypotenuse, in ABD triangle we are taken the hypotenuse, correct. Next, here in ABC triangle we are taken the base, here base C, and ADB triangle base we are taken. So that implies you can write BA square will be equal to BC into BD. So BC into BD, that implies AB square will be equal to BC into BD. Hence it is proved. Hence we are proved the first one. So that is the first one. Let's write it second one. So for second one proof, what is that? You can take triangle, let triangle ACB. So here ACB. So we are came from top to the base, and another triangle DCA. So DCA. So we are consider these two triangles now, DCA. So DCA. So base to the height. Here also ACB, height to the base. Here also height to the base, DCA. So in both the triangles, angle, why we are taken ACB and BC DCA? So we are consider BC DC is there. For that we are taken. So angle ACB will be equal to angle DCA. Angle DCA, that will be equal to 90 degrees. And another one, here 90 degrees are there. So provided, so what is that angle? Both the triangles, angle BAC. So angle BAC, this angle will be equal to angle ADC. Can you take it like this or not? So angle BAC, this angle will be equal to angle ADC. So here this angle and this angle will be equal. Why? Because what you can take it here as proved in a first one. Proved in first one. Why? Because from proof 1. So both are similar to each other, then what you can write it, both angles also similar, equal to each other by AA similarity criterion. Similarity criterion, what you can write, AA similarity criterion, what you can write it here as triangle ACB is similar to triangle DCA. So from that ratios you can take it as AC by hypotenuse, this is height, AC by, in the height will be equal to DC, that will be by DC heights, and you can take it as here BC by both the triangles, what is that, CA or AC. So that implies what you can write, AC square will be equal to BC into DC, hence it is proved second one. Then let's write third one, hence we are proved. So in triangle, let's consider AD square will be equal to BDCD. So for that you can take it, let triangle ADB and triangle CDA. Why? Because ADB total 1 and CDA. So CDA. So in both the triangles, angle you can take it as DAB 90 degrees and angle DCA 90 degrees, DCA 90 degrees. And one more thing, here common angle is there, angle BDA will be equal to angle ADC, that is common angle. So by using of AA similarity criterion, what you can write here, by AA similarity criterion, corresponding sides, ratio of the corresponding sides will be equal to each other. So for that, let's ADB is similar to triangle CDA, So by AD by, let's write it here, AD is there. So in this triangle AD, that is height, and this triangle CD. And we can take it as here BD we required. So BD hypotenuse. So BD by here hypotenuse will be AD. So from that AD square will be equal to BD into CD. Hence it is proved. That is third one. Hence proved. If you like the video, please like it, try to share with your friends and family members. Don't forget to subscribe. Thanks for watching.